Tech teardown time. What could be better than toggle switches and tubes? So many tubes, it's air cooled. Let's open this thing up and see how this precise time mark generator is put together. Maybe it'll even still work. Let's find out. Just the fact that this thing was made by Tektronix way back when, you know this is going to be a very cool circuit inside. Care to guess how many vacuum tubes live within this box? It has a fan on the side. Well, let's find that out together. It's pretty heavy, I can tell you that. So they have a very big power supply inside this thing. So I don't know if it'll power up, but we can definitely try. Looks like somebody way back when has painted the case. These things always come apart very easily. So you just stick a screwdriver in here and give it a twist. Like so. Sounds like it's settled. Right now, what I'm going to do is lay this on its face, like so, on the soft mat. And let's take a look. What we got going on this side here. You get to see the bottom first. Look at that. Get this thing out of the way. Well, something's been leaking. You see that down in the bottom there? Right there. Something's definitely been leaking in the bottom. So one of these capacitors has definitely leaked something out of it, which isn't a good thing. So we'll find out what's going on with that. All right. There's some tubes right there. Now don't be fooled. Wait till I show you what's in between here. So power supply on the bottom, fan, does the fan turn? It does. Filter capacitors, power supply. Tektronix liked using the 6AS7 or 6080 tube as a pass element, so basically high voltage regulation circuit here. Some references and probably some other pass elements. There is a sea of tubes in this thing. Look at this. I bet you this would look very nice in the dark, all lit up. Looks like they've got a lot of 12AU7s with the getter on the side with a clear top. So clear top 12AU7s. Audio guys absolutely love those. They're a very nice looking tube when they're lit up. It has a lot of them. They're all over the place here. So it would be a lot of fun to power this thing up. It looks like it has some pretty decent parts inside here. I'll zoom on in. So whenever you see the red writing on these capacitors like this means that they're a dye-film style capacitor. If the writing is yellow, that means that they're a paper. Basically it's paper and foil, not paper in oil. Two different caps. These here looks like capacitors look like they could be capacitors that would fail. Most of all the other caps are all, you know, not film style, poly style capacitors. I guess that is a film. You really want to get specific, but yeah, poly style caps. Yeah, it looks very nice in here. Look at all the tubes. So basically what this thing is one big giant frequency divider. And it has a crystal in it, so that would be the crystal. So this thing should be heated all the time in order for this thing to be accurate. So this thing would be on all the time. And we'll find that out here in a moment when I plug it in. I imagine on the bottom here, I'll zoom in just a bit closer. The crystal oven should be on all the time, so that little bulb should be lit if it's still working. AC power is going to be sketchy with that capacitor on the bottom. So let's see the capacitor on the bottom. I'll have to do a tube count as well here, and you can see if you were right on the tubes. So which one was leaking? Let's see. Looks like C401. C401 is leaking. That's what's going on here. So I'll zoom in. We'll hold this up. That's heavy. You can see that. It may still work. Like somebody has taken the time to write voltages and capacitance on the bottom side here at some point in time. This would be a really neat candidate to restore. Of course, you know, ooh, look at these bumblebees. You know, those are trouble. So these will definitely be trouble. All the guitar guys are like, don't harm the bumblebees, save those. So basically this unit is that thing right up at the top there. So this is the unit that they would use at Tektronix when they were, you know, aligning and doing all that stuff with their larger oscilloscopes. They'd have one of these. This works just fine, but this unit down here is basically the scaled down version of this one. That's all that is. This one's, you know, huge. This is the size of a, well, probably, yeah, about pretty close to the same size as a 500 series scope. And you know, air filters on it, and you know, a sea of vacuum tubes in that. I did a video on that one as well, so that goes back some time. I haven't had to do anything to it. I was going to take it apart and restore it, but the thing just keeps working and working. So what happened, I found in the early days of tech, they were using really good parts, but I guess some of them slipped through the mix. They used some bumblebees and things like that way back in the day. But for the most part, they came into a time period when a lot of their equipment just stayed working. I have, as you know, I have many 500 series tech scopes, and a lot of them you just plug them in and they work. They work just fine. They're even still cal. Like, I mean, they're so close. You know, it's actually very surprising. So there was this period that the parts were just, you know, incredibly high quality. A lot of the times these filter cans, they don't fail. You know, they keep going. This one's a little loose. Look at that, eh? So obviously this has been inside. The case has been repainted, so you know somebody's been in here. Oh, look, and it still has the silver bearing solder in the back. Look at this. Still in the back. Let's see if we can zoom in that. So this is in the days when the manufacturer is like, hey, fix your stuff, right? Nowadays, do you think you'd ever see like a manufacturer, say you buy a new computer, do you think there'd be a roll of solder in it telling you to fix something? Right, look at that. So they even give you solder to fix it, and you need to use special solder because of these ceramic strips here, or these little, basically horseshoes will, I guess you could say, debond. They will let go of these ceramic strips inside. So yes, looks like a really large multi-vibrator setup. Diodes and triodes. Diodes and triodes. So I'll have to dig out a schematic on this, and we'll take a look at a schematic and see what goes on in this thing. So I'll go do that, and we'll take a look at some of the circuits here, and we'll try and power the thing up and see what happens. See if we can make some more smoke than it probably has already lit off. Multi-vibrator madness. Lots of them inside this. You can look at this through modern eyes like a whole bunch of flip-flops is what this really is. So we have our multi-vibrator here doing its magic. In order to tell this thing what to do, we need a trigger pulse. So that comes in here through this 6AL5. That is another tube. So we have one tube here. So this is one part of, there's two parts in one tube, but this is one part and another part in one glass bulb. So two diodes in one bulb. Same thing here with the 12AU7. We have two triodes inside one 12AU7. In modern eyes, you can look at this like it's a FET. So vacuum tubes are very close to field effect transistors in the way that they operate. And then we have one other tube here, which is a 6C4 on the out. So what's happening here is this is acting like a flip-flop. In order to tell this what to do, we need a trigger, or sync in this case, which they're calling it here. This is, you know, doing its multi-vibrator madness, and this is providing drive. So this is a cathode follower, so it's giving us a little bit of current here at the output. And you can see they're showing this as a shielded cable. And there's just lots of these things in this unit doing frequency division. It's just a high frequency divider chain. And that's really what this is. So move on to the actual reference here. So we have, this is the crystal reference in here. So a crystal oven really is what it is. And that was that little block that we looked at inside. So hopefully that works. So we have our oscillator. And really what this thing is a frequency multiplier circuit. And how these work is pretty much like the old, say, Heathkits and E.F. Johnsons and all that, those old ham radio AM transmitters. They have a thing inside called a harmonic amplifier inside. And that's basically what this thing is doing, is all they're doing to get their multiplication is they're tuning these things to different harmonics. And so, you know, you'll tune this to either 5 or 10, or in this case, 50 megacycles, and they're just picking up a harmonic, and what they're doing is they're tuning it to make it really strong, so they're getting their frequency multiplication like that. So really, really close, a little different, but very, very close to what you'd find in a lot of old ham radio equipment. So next time you, if you're a ham radio operator and you're looking at some old AM equipment and you see a vacuum tube called a 5763, that's the number of the tube, and they use those very commonly in the frequency multiplier. Basically, again, just a harmonic multiplier amplifier type circuit. So 6CL6s are used as buffers and 5763s are used as multipliers. In this case, they're using 6AH6s in this circuit to do the same thing. Very neat. Not much more to this. You know, the crystal, of course, you know, we have our crystal right here, right? We have our heated crystal, which is temperature controlled. So basically, there is a little resistor in here which turns on to heat that crystal to keep it very stable. And then of course, once it gets to set temperature, the switch opens, the resistive element inside shuts down until, you know, the heat inside, you know, goes down to a certain rate and it'll come back on. So we would see a little bit of a cycling effect, and you know, using a crystal like this. Not like the more modern ones where they're, you know, kind of in a linear region. This is, you know, on or off, done with a usually a bimetal strip or something like that inside the can. So again, the reason that they have to heat a crystal in order to make it temperature stable, or, you know, more temperature stable, is because when you heat something, parts expand, and when they cool down, they contract. Well, if you have two plates and they expand, you're going to get more, you know, higher capacitance. And then of course, if it cools down, you're going to have lower capacitance. Well, that incurs frequency drift, and it's the same thing with pretty much everything. So you know, things expand and contract with temperature differences, and expansion and contraction means things moving closer together and further apart. And in electronics, that basically causes frequency either to go up or down because of capacitance variation and things like that. That's the reason that they need temperature control inside these things. Now, in some units, you know, really, really precise temperature control isn't all that incredibly important, and in other devices it is. So a lot of times in modern equipment, you'll see a thing called an OXCO, which is an oven-controlled crystal oscillator, things like that, right? So power supply. So very simple, huge transformer inside this thing. That's what's making all the weight. We have a vacuum tube rectifier here and diode rectifiers up here, filament windings, very common, kind of just rinse and repeat to a lot of tech equipment. So you can see we have a reference down here, and we have a pass element, and of course we have the control right in this area right here. This is the -135. You'll notice that we have pass elements up here with control and pass elements with control, but you don't see any reference here. And this is typical of tech. What they do is they use basically one circuit as a reference for all the rest. So you can see we have -135 here. The -135 is put up here and right here as well in order to keep these accurate. So if this goes out of basically out of regulation, everything else here would be reflected. You know, so we'd have a reflection on the rest of the circuit. So it would be, you know, I guess you could say the most prudent to tune this circuit first and then go after the rest of them and make sure all the voltages are correct on the rest of the circuits. So this one would have to be adjusted first, and you would check the rest. Very simple. You can see that we have a lot of filament windings. The reason that they have isolated filament windings in this is because a lot of these vacuum tubes, the filament to cathode breakdown could be exceeded. So by isolating the filament winding from everything else, you lessen the chance of breakdown so that you don't get any short circuits and things like that. It's a very standard power supply circuit. Very neat. That's really all this thing is. You know, lots of parts and pieces. You can kind of look at it as, you know, very, what would the word be? Very simple and very just, you know, one by one. You know, everything nowadays is in an IC. You have conglomerations of parts. Well, you can look at each one of these tubes as basically 2 transistors or 2 diodes. And of course, we have some other tubes in the bottom here. So everything is just basically like a single part doing its job. So that's why we have so many of them, right? You know, nowadays, you know, one IC would probably do all of this, but it wouldn't be that exciting, would it? This thing here is going to light up like a Christmas tree, and I'm looking forward to seeing it, and hopefully you are too. So I don't know if this is going to make any smoke when I power it up because that capacitor looks bad. But you know what? I'm going to power this thing up. I'm going to plug this thing in, turn it on. I'm going to let it baste on my dim bulb tester over here for a few moments, and I'll be right back. All right, let's do this together. If we're going to see smoke, we're going to see it together. So I put a 300 watt bulb in there because, you know, these bulbs here are just too small. So what I'll do is I'll turn this on. The variac is just maxed, and I'll put this to current limit, and let's see what we get. Okay, so nothing so far. But we do have a crystal light on the front here. So the oven lamp is on. That's a good sign. Something's working. So this is when all the fun happens. So let's see what happens here. We'll zoom into this. What do you think is going to happen? Here we go. That's pretty bright. Oh, the fan started and it is dimming out. You see that? It's dimming down. So that's a good sign. The fan is going. The crystal light has gone out already. I don't know what that's about. Maybe it's cycling already? If so, that would have warmed up pretty quickly. So, let's see if that crystal unit's actually hot. I'm going to be very careful. I'll show you what I'm doing here. I'm going to be very careful, and I'm going to put my hand in here and... That's warm already. So maybe it's already cycling. Interesting. Oh, it's on dim now. Crystal light came on dim. I have a feeling that probably needs to be taken apart and cleaned. Let's see if I tap it. No, the crystal light came... Oh, no, it went out again. So maybe the bimetal strip inside here is... Maybe the bimetal strip is not making full connection. That's a very good possibility. Well, it is cycling, so hey, you know, we do have some sort of action going on. And the fan is going. And the lights up top are, well, not crazy bright. But it could also be the reason that this is so dim right now is because I have the rest of the machine on and it's pulled the line down. So what I'll do is I'll flip the bulbs out and give this thing full current. Here we go. Oh yeah, that is brighter now. So obviously it was just pulling the line down. I don't see any smoke yet. Let's see what's going on. Yeah, the reference is lit up. The 6AS7 is doing okay. So this is the negative 135 adjust. I wonder what's going on the bottom here. So I got my voltmeter warming up. What I'll do is I'll tip this on its back. So I got to be super careful where I put my hands on this because I only want to touch the chassis and nothing else. Okay. So what have we got? So that is the capacitor in question that's been leaking. Let's see here. This is all on the fly. So let's grab some leads and I'll take a look. All right, got a couple of leads over here. Put this into the meter and clip this to ground down here somewhere. Back you out so you can see what's going on. So this looks like a good ground. And this is DC. So I will clip this to the 135 volt supply. That should be right about there. Ooh, we got 150. Got 150. Let's see what happens if I turn down the supply. Oh yeah, it is adjusting. I can adjust that up to 135 right there. So it has been played with. That was way out of adjustment. That VR was in outer space. So there it is. There's the negative 135 volt supply right there, and it's 135.0. And all I did to do that was right on the top of the chassis is that VR that we saw, the negative 135 volt supply. All I did was just twist that. Right there. Just twist that. So I'll move you over to that so you can see that. I can find it. There it is. Focus on that, please. There we go. Right here. So I just twisted this. And that brought that into adjustment. I'm not seeing any smoke, even though it did leak. I wonder if the filter is actually, it must be working because there's quite an adjustment range there. If there is AC on that, there would be a problem. So I don't think I would see that adjust so easy. So what I'll do is grab this so that you can see this at the same time here. This is all on the fly. So, okay, so I got this on AC now. There, so you can see it without the glare of all the lights. Give me 1 sec, I'll adjust that again. And okay, so have we got any AC on this? We'll go to the AC side. Not to the AC side, I should say, to the filtered DC. Yeah, there's a little bit of AC on that, 1.1 volts. So the cap probably, definitely could get changed. But if we go to the output where it's 135, look at that. Filtering is, because it's a pass element in there and it's regulated, look at that. There's zip for AC on it. So I could probably use a filter cap. I'm sure that cap is definitely tired. It's not spraying anything. It's not leaking anything right now. So anyways, so we looked at the output of the rectifier, and then we also looked at the filtered output. So there's a little bit of AC right at the rectifier. So not so bad. So now what we need to do is shut the lights down and take a look at the sea of filaments that's behind here. All right, I've got the camera scanning really slow so I can get the full brightness of the tubes. Look at that. Just a sea of vacuum tubes inside this thing. You can imagine the current draw on that filament transformer. Look at that. Doesn't that look fantastic? The focus here down just a little bit. Look at that. A little bit of focus up here. Don't those filaments just look fantastic? You almost want to run something like this in the dark while you're using it. It just looks so good with all of that filament goodness. So how many vacuum tubes do you think? Well, there's 54 tubes in this thing. No wonder it's got a fan on the side of that box. This thing would be an oven in a very short period of time. Its own little oven. Red and green light on the front there. Doesn't that just look fantastic? So when you hear people say these older pieces of electronics, they just have this magical glow, and even, honestly, even the smell of this unit, it just has such a great smell while it's operating. I guess all the hot vacuum tubes. For those of you that have vacuum tube equipment, you'll know exactly what I'm talking about. There's a certain magic about this old equipment that, well, I guess you just don't know unless you've been around this old equipment or you've worked on it. If you're a solid state guy and you like solid state equipment, you're watching this stuff and you've never experienced having an older piece of equipment and just the actual smell of the electronics and the glow, you really don't know what you're missing. I'm telling you. Great. So it is cycling. So that oven, which is right here, is cycling inside this thing. So if I put my hand on the case here very carefully, if I can maybe bring the temp down just a little bit so that it'll come back on. Sink the case off the heat off the case of the crystal with my hand. It is warm. It's nice and warm. So that's a good thing that it is cycling. There it is. So it is working. There it is, on and off. Contacts could probably be cleaned inside there. This would be a really neat restoration. I'm actually looking forward to doing this now. You know what I'm going to do is get an oscilloscope and attach it to the output, and let's see if the thing's actually giving us any signals. All right, so it's on markers, and I've turned all the markers off, and I will attach the scope, and let's see what we get. I'll worry about the glare in a moment here. Trying to adjust that for minimal glare. Okay, so I need to connect to this, which is signal output. I'll attach the common to here, and I'll just clip this on the back side of the connector in the actual scope. If this will grab onto it, hopefully it will. Grab onto it. That's a little bit slippery on the back. Okay, scope attached. Move this over just a touch. And okay, here we go. So 500 microseconds. Is it going to give us anything? Look at this. It's not bad. So this is 200 microseconds. Let's go to 500 microseconds. It's there. It needs alignment, but it is there. So just for the fun of it, there's 500 microsecond adjustment in here. Let's see what happens if I just give that a twist. Now, of course, this thing needs a full alignment, and I'm just doing this for fun. There's an order that this has to be done in, and I'm not doing this in any specific order. I did have my other insulated tool around here, but doesn't seem like it's around. So there we go. Let's see if I can move this around. Oh yeah, there we go. So it's a little, yeah, it's dirty. Getting closer. Nope. Was getting closer. Yeah, it definitely is unstable. So I think I can probably, what I'm going to do is just move the adjustment on the side. The adjustment on the side is right back here, so I'll just stick this in here. It's chassis ground. Let's move this back and forth a bunch of times. Probably. Okay, let's see what we get. Well, we were pretty close there. So it might even be, probably need to go right back to the oscillator and start there. Make sure the oscillator is actually doing what it's doing, because it gets to an area and then it gets unstable and kind of bumps above it and below it. You can see that. Could also be that filter cap. Could be all sorts of things, but it is happening. So you can see it's just a little bit off. We get a couple of them online and then it goes out. So let's try the 100. And let's go 100. It's there. Again, it's off, but it's there. And let's try 50 microsecond. Yeah, they're all there. It just needs alignment. It's working. Look at that. $50 microseconds, right? Not bad. So let's just go right down to 1 microsecond. 1 microsecond. That one's close. That's almost right on every bar. Not bad. Okay, so with that, let's see if we know that the division is working. Let's see if the sine wave output is working. So this would be the multiplier now. So we know that division's doing okay. Let's see the multiplier, what we got here. I'll put this back onto auto, so it'll go here. Five megahertz, spot on. So let's go to 10. That 10 looks like it could have a little bit of help. But it's there, 10 megahertz. And let's try 50. Look at that, 50's doing okay. 50 megahertz, it's all there. So the entire division chain and the multiplication chain seems to be working. So really, it just needs an alignment. Of course, parts changed. Get rid of the bumblebees and change out the electrolytic caps, and this thing would be absolutely fine. Of course, fix that horribly noisy fan. See what happens if we push on the case with an insulated screwdriver here. That's a little more like it. So definitely that side. That's just air noise now. So not bad at all. A little bit of TLC, and this thing could be used to align oscilloscopes. And it's oven controlled. It has a crystal oven. So this thing would be really accurate once it's cleaned up and aligned. Oh, and by the way, for all of you that commented on the previous video regarding the Hammarlund SP600, I'm going through with that restoration. In fact, that's in progress right now. So I'm working on the Hammarlund communications receiver restoration project, and you'll have a video here not long from now. So all of you that left your comments below and said that you would like to see the restoration, all of you are responsible for that. So if you didn't leave your comments and I didn't get as many comments as I had gotten from all of you, I wouldn't have gone through with this. So 2 thumbs up for all of your comments and for your feedback regarding that communications receiver here and on Patreon as well. I got a lot of feedback on Patreon. So there you go. A lot of restoration projects coming. This one here will be a full restoration, and I will do that as well. I will share that process with you in the near future. If you'd like to understand more about electronics, both modern and antique alike, I have an electronics course on Patreon that's very in-depth, and I teach in a very different and effective way, so you may want to check that out. I'll put the link just below the video's description under the Show More tab, and I'll pin the link at the top of the comment section. If you enjoyed this video, don't forget to like and subscribe. There'll be many more teardowns, repairs, restorations, all of that great stuff coming very soon. All right, until next time, take care. Bye for now.